Hello everyone, my name is Adi and I'm coming your way again with another wonderful problem walkthrough section under the topic Surds. So if you have not gone through the video through which we discussed Surds, you might want to go back to it to familiarize yourself with the concepts. In this particular video, I'll simply be solving some problems with you. I'll be going through various examples and sets to help you to better understand the topic, because with math, you solve many examples if you want to be very good at it. So we are going to go through some examples and I hope it helps you. So let's look at the first example. Let's get right into it. So it says simplify square root of 50 minus root 2 minus 2 root 18 plus root 8. Root 50 minus root 2 minus 2 root 18 plus root 8. The first thing you want to do is to simplify each term. And so when you look at the first term, which is root 50, we are going to write this as the product of a perfect square. And what I mean by a perfect square is a number which will produce another whole number when the square root of that particular number is found. So when you find the square root of a number and you get a whole number, then that number is a perfect square. So the perfect square we can think of in this case will be 25. 25 times 2 will give you 50. So minus root 2 minus 2 root 18 will also need to be broken down into a perfect square and another number multiplying that perfect square. And in this case, we can think of 9 times 2 plus root 8. And root 8, we can also further simplify root 8 by writing it as the product of a perfect square and 2. So there we have it. We can further simplify this by knowing that the square root of 25 is 5 and the square root of 2 is root 2. And you have your minus root 2 minus 2 times the square root of 9 is 3. So this 3 is coming from the square root of 9. This 3 is coming from the square root of 9. And the square root of 2 is 2. And what I mean by the 2 is this particular 2 here. That's what you see here, the square root. Plus 2 root 2. And this 2 is coming from the square root of 4. Let's continue. So from here, we have 5 root 2 minus root 2 minus 2 times 3 is 6. 2 times 3 is 6. Root 2 plus 2 root 2. Fortunately for us, every single term has root 2. So we can simply add all of them. So 5 minus 1 minus 6 plus 2. So I'm adding all the coefficients of each set because they are all having root 2, so they are similar. So I can just write this root 2 as the common set. 5 minus 1 is 4. 4 minus 6 is negative 2. Negative 2 plus 2 is 0. So we have 0 root 2. And that gives us 0. You can pause the video and take notes of this example if you couldn't have it. If you were able to get it correct, congratulations. We are going to go through another example, so don't be worried if you couldn't get this one. So this video, as mentioned earlier and as promised in the previous video, is simply a video that will tackle questions. It's a problem walkthrough series that we are going through. So let's take another example. Root 28 plus root 175 minus root 63. You can pause the video and try this problem while we go through. So let's go through this problem. So we need to simplify each of the 3 terms that you see in this problem. And the first term, which is 28, can be written as 4 times 7. Remember, we are always looking for a product which is a perfect square. So plus 175, you can think of 25 times 7. And then with 63, you can think of 9 times 7. The square root of 4 is 2. The square root of 7, root 7. The square root of 25 is 5. The square root of 7 is root 7. The square root of 9 is 3. And the square root of 7 is again root 7. Again, we have similar terms in here. And because we have similar terms, we can add the coefficients of each set. So we will have 2 plus 5 minus 3 root 7. And this will be 2 plus 5 is 7 minus 3, that's 4. So you have 4 root 7 as your final answer. I hope you got this right. And if you did, congrats. If you couldn't, don't worry, we are going to go through some more examples. Let's look at some interesting multiplication problems in sets. Okay, so says simplify 1 minus root 2, all multiplying the expression 3 plus 2 root 2. Now, I mentioned earlier that when you have these kinds of problems, you can choose any of the two terms. So this is one term and this is another term. You can choose any of those two terms, write it twice, and then you distribute the subterms over each term. So in this case, we are going to choose the second term and we are going to write the second term twice. So let's do just that. We have 3 plus 2 root 2, and then we're going to write it again. 3 plus 2 root 2. And then we would distribute the subterms of the other term across these two expressions. So we have 1 multiplying the entire expression here and negative root 2 multiplying the entire expression there. So we are going to multiply 1 by 3, 1 by 2 root 2. We are going to multiply root 2 by 3, and we're going to multiply root 2 by 2 root 2. So 1 times 3 is 3. 1 times 2 root 2 is 2 root 2. Negative root 2 times 3 is negative 3 root 2. Negative root 2 times 2 root 2 will be negative 2 times root 2 all squared. Remember, we have root 2 here and root 2 there. So if they are multiplying, we have root 2 squared. So over here we have 3 plus, since these two terms are alike because they both have root 2, we can simply combine their coefficients. And we know that 2 minus 3 is going to be negative 1. So we can write negative root 2. 2 minus 3 give us negative 1. And normally with sets, if it's 1 that is the coefficient, if 1 is the coefficient, you leave it as such. You don't write 1 root 2. You can leave it as root 2, and that will mean root 2. So let's move on to the last term. The last term says minus 2, and we've learned something about the square rule, that root 2 all squared would mean 2. So we will have 3 minus root 2 minus 4, which is 2 times 2. We have to group like terms because remember, this is a whole number, this is a surd, and this is a whole number. And since we are dealing with the subtraction of surds in this particular line of the problem, we will have to group the whole numbers at one end and the surds at one end. So we have 3 minus 4 minus root 2. 3 minus 4 is negative 1. And you have negative root 2. I hope you were able to get this answer. So let's try some more examples. They are very interesting, and I believe that as we go through these examples, we will be getting ourselves familiar with surds. So you're going to try another example. Of course, you can always go back, since it's a video, to copy the notes. Right. Okay, so this one says if root 3 equals 1.732, find without using a table. Two over root 3. Correct to 3 significant figures. Very, very important. So let's solve this problem. So we have 2 on root 3. To solve this, we have to first rationalize the fraction as we have learned previously. So we have 2 over root 3, and you simply rationalize by multiplying it by numerator and the denominator equal to the surd in the denominator. So that is the rule. 2 times root 3 is 2 root 3, and root 3 times root 3, as we have established, is 3, because that will be root 3 all squared. But the question mentions that root 3 is 1.732. So we will simply substitute root 3 for 1.732 and simplify. So when we simplify, 2 times 1.732 will be 3.464. And when we divide it by 3, we will get 1.154666, recurring, as you can see with the dot on top of the 6. And when we approximate this to 3 significant figures, we will have 1.15. 3SF means 3 significant figures. Let's try one last example, and we'll be through with the problem walkthrough. One last example. And we'll be through with sets. But it doesn't mean I am done with you, because if you send me a problem, I will be able to help you. So do well to send me any question that you have, and I will be able to assist you in that regard, so that we will all benefit from this project. Okay, so let's tackle this. It's a little complicated, but I believe we'll be able to do it. Let's try it. Say simplify. So there's a fraction consisting of this numerator, root 3 plus root 12 plus root 108 minus root 75. and the denominator is root 6 minus root 96 plus root 150. You can pause the video and try this problem. Alright, let's go through it. So we'll simply go ahead and simplify these sets. So we have root 3 and root 12 can be written as root 4 times 3 plus root 108 can be written as root 36 times 3 minus root 25 times 3, which represents root 75. And then we have the denominator, root 6 minus 96 can be written as 16 times 6 under the square root. Then plus 150 can be written as 25 times 6. Now, let's simplify this further. So we have root 3 plus the square root of 4 is 2. And the square root of 3 is root 3. We have plus the square root of 36 is 6. And the square root of 3 is root 3. Minus, we have root 25. And the square root of 25 is 5. And the square root of 3 is root 3. Now let's look at the denominator. We have root 6 minus the square root of 16 is 4. And you have root 6 plus the square root of 25 is 5 root 6. Now we can simplify this further since we have root 3 as a common set in all the terms in the numerator. We can have 1 plus 2 plus 6, which is 9, minus 5, which is 4. So we will have 4 root 3 all over. The denominator also have common sets of root 6. So we have 1 minus 4 plus 5. And that will give you 2. Because 1 minus 4 is negative 3. And 1 minus 4 is negative 3. And then negative 3 plus 5 is 2. So we have 2 root 6. We can further reduce this fraction because we have 4 on 2. So 2 will cancel itself once and go into 4 twice. So we'll have 2 root 3 over root 6. But we are not done. The reason why we are not done is because we have a set in the denominator. So when you equate this to the rationalization process, you simply treat this by multiplying it by root 6 over root 6. And this will give 2 root 3 times 6 all over 6, because root 6 times root 6 is root 6 squared, which will be 6. So this will give 2 root 18 over 6. However, root 18 can further be simplified. So we have 2 over 6 times root 18. And root 18 can be written as root 9 times 2 all over 6. Now this will now yield 2 times 3, since 3 is the square root of 9, then root 2 all over 6. 2 times 3 is 6 over 6 root 2. And 6 will cancel the 6 in the numerator. And so our final answer is root 2. This brings us to the end of these problem walkthroughs. There are many other examples that I would love to solve with you. And for that matter, if you have any questions or you need any further problem walkthroughs, feel free to contact me through my email. Also, do not forget to like my video and subscribe to my channel. Share it with your friends, and I hope to see you in another video, and I hope to spend another time with you. Thank you very much. Have a wonderful day. Goodbye.